we have seen that we can think of the work done as a component of force in the direction of displacement times the displacement. Now there is another way to think of this, which is described more commonly in textbooks. Now this is how it works. So let me backtrack to what I started off with. Right. Okay. So at first I have the force and the displacement. Okay, and let's say, and I tried to calculate the work done, and I got 150 joules, which I said is not correct, because the component of the force in the vertical direction is actually not doing any work, since there's no motion vertically. The box doesn't move down. Now there's another way to do this. There's another way to do this, which is instead of thinking of resolving the force into the two directions, one along the displacement and the other perpendicular to it, and then saying that the perpendicular component has no effect on the work, we can instead think of the displacement. Okay, so let's see how we do that. Okay, the displacement is this vector from all the way from the box over the distance and in the direction of the distance moved. So this vector here represents the displacement. Right. Now, so instead of thinking of the force, I can think about resolving this displacement into two components. One component along the force and one component perpendicular to the force. So let's see how we can do this. So I'll just extend this line. Okay, and I'll extend that line. So I think of a perpendicular direction to the force and a direction along the force. Okay, so these are perpendicular directions. Now, and I'll resolve the vector, the displacement vector, in the two directions. The one along the force, so I do that by dropping perpendicular to the line along the force and thinking of this vector, this arrow here, all the way from there to there as one component, and then I drop a perpendicular from there to there. Okay, so here goes something like this. So this vector here is the perpendicular component to the force, right? And if we think of actually calculating these two components, you'll find that the component along this direction, along the force, has a value of has a length of 2.4 meters, and the component along that other direction, okay, we shouldn't worry about that, right? So along this direction, yes, 2.4 meters, right? So, and then we can in terms of displacement, we can now say that since the component along well, this component which is perpendicular to the force, this component of the displacement, we can say that no work is done on that part of the displacement, because the force is not going in that direction. The force is going in this direction. Okay, so the part of the displacement that has received work from the force, okay, would be the component that is along the force, the 2.4 meters. Okay, so then by this reasoning, therefore, if I want to calculate the work done by taking force times distance, I really should not multiply 50 newtons by the 3 meters. Okay, I should multiply should not multiply by the original displacement. I should multiply by the component of that displacement along the force, which is 2.4 meters. So instead of 3 meters here, I should take 2.4 meters. Okay, and if you multiply 2.4 meters by 50 newtons, we'll get the answer as 120 joules. And we would get the same answer as previously when I did this by resolving the force into a component along the displacement and a component perpendicular to it. Okay. So this gives us another way of describing the work done, and a way which you see more often in textbook, which is that the work done is equal to it's equal to the force times the displacement in the direction of the force. Okay. Now, although this if you like, definition of the work done, we often insert the work done here, work done. Although this definition of work done is, you'll find this in textbooks, instead of the other one which I described previously about taking the force in the direction of the displacement times the displacement. Although this version is more commonly seen, it does not mean that this version is should always be used or even is always more useful. It quite often happens that it can be more convenient to use the other version, all right, which says that work done is the force in the direction of the displacement times the displacement. Okay, so in other case, what we need to learn is that to do this calculation, we can either do it by finding the component of displacements along the force, or we can do it by finding the component of the force along